All right, so we're going over some homework questions, and we're looking at last night's worksheet 25 and 26, and there was a request for number 19. So on the answer key, there is a hint for you on number 19. And these two observers who are standing 600 feet apart on opposite sides of the flagpole, the angles of elevation from the, okay, blah, 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 are 19 and 21. And then find the height of the flagpole. So the question that you actually have to answer at the end of this question is this, which I'm going to call H. However, this is like a line that's not within your oblique triangle, and we know from our experience with these that you're going to probably have to do these in 2 steps. So the hint says first, find X, and I think I labeled X over here on the key, so you knew what I was talking about. Technically, you could have found either one of the legs. It didn't really matter. So let's fill in some more of these clues that they gave us. So the observers are 600 feet apart from each other. So like this is one of your observers and this is the other one. So the entire distance here to here is 600. And then the two angles are 19 and 21. And it doesn't technically matter where you put the 19 and the 21 for the angles of elevation. If you want to follow along with what I did 19 degrees here and 21 degrees here. But again, it really, honest to goodness, does not matter. Thank you. Okay. Then, I think we have enough information to use, we have an angle, side, angle, so which law are we going to be utilizing first? Angle, side, angle is sines. So, we're going to have to set up a law of sines to find x, but the problem that we're going to run into right away is I need to figure out this angle so I can use that angle along with the 600 side. But that's a geometry problem. So real quick, geometry question, 180 minus 19 minus 21, 140. Okay, so that's going to be the start of law of sines. So sine of 140, what mode are you in, by the way? Degree mode. Sine of 140 over 600. Equals, and since we want to find x, you're going to use the 19 degree angle. So sine of 19 over x. All right, so I'm going to stop helping you with that question. You're going to find x. You're going to be able to fill that in. And then I want you to focus, whoopsies. I want you to focus on, oh man, tablet, come on. This triangle that I'm desperately trying to highlight. That guy. And it's a little kid trig problem now. You have an angle. You have, you're trying to find this, I shouldn't have called it H, that's confusing. It's not the hypotenuse, but you're trying to find this leg of the triangle, and then remember you're going to have a number for this guy. So you're going to set up what trig ratio? If you have opposite and hypotenuse, you have sine, very good. So your second part of the question is to set up your sine ratio. Okay? It's not the only way to get the answer. There's multiple ways. So if you went a different route, but you still ended up with the same answer, that's fine. The point is, what I need to see on that question, various algebraic setups. At no point should I see like, oh, the answer is, and by the way, the answer is, I didn't write the answer down. Well, what is the answer? Thanks. Where's 19? 108.9 is the answer. My bad.
Hey, so after you do like
the law of sines?
Yeah.
Yeah.
So
that number goes here on this triangle, but you see like in this picture there's 3 triangles.
Yeah.
So then your focus is going to go to this little right triangle, this red one that I highlighted. And you can set up a sine ratio because it's a right triangle. Some kids insist on like always doing law of sines for regardless of what kind of question it is. So like they'll do law of sines on that red part of the problem too. It's not going to be wrong. It's just a little overkill in my opinion. All right. What else? You want to stay on this worksheet for a minute? 16. Let me guess, it has a hint. All right, number 16. Oh, 16 is not too bad. What I'm going to do is I'm going to help you with the drawing, and then I'm going to leave you alone to finish it, okay? So 16 is a question that we used to see a lot on the ACT tests, but since we don't often give the ACT tests anymore, you guys might never run into it, but I know math team kids see this one a lot. So we have a parallelogram. 2 adjacent sides are meeting at an angle of 35 degrees. So when you have a parallelogram, a parallelogram like this. One of the angles is obtuse and one of the angles is acute. So if it says they meet at an angle of 35 degrees, that means this acute angle here is 35 degrees, and therefore this one is as well. But because of the definition of a parallelogram, this angle is going to be the supplement to that angle, because this same side interior theorem back from geometry. So 180 minus 35 is, oh, you know what? I don't even think I need that. What's the question say? What's the length of the shorter diagonal? So this versus that, you got to figure out which one's the shorter diagonal. It should be across from the shorter angle. So it's that blue line that I just filled in. There's some other clues here. The sides are 3 inches and 8 inches. So using the picture that you have, make the shorter side 3 and the longer side 8. And they want to know this. So you have a side, angle side. So what law should you be using here? Cosines, go for it. All right, what else? Want to move to a different assignment? Anything else on worksheet 25 or 26? Okay. All right, what else you need? Let's stick with the homework check for a minute. So you guys had some book work on law of sines and cosines on page 298, and then page 299 was the area questions. So yes, ma'am. 19 on 290, whatever. Where's 19 at? Ah, fun. Okay, so they flat out told you that you're going to have 2 triangles. So that's helpful. Let me figure out a place to... There we go. All right, so we are looking at page 298, number 19. And the directions say, find 2 triangles with the given measure and the side lengths, round to the nearest tenth. Make sure you guys are in degree mode here. And they give me some clues on 19. The clues are that you have angle A, and side B. So I draw a really cruddy triangle, which is never to scale, and that's okay. But labeling the triangle is probably the most crucial part, because sometimes kids label the triangle wrong and then you get problems. So angle A is 39 degrees. And then lowercase a means side A, so across from him is 12. And then side B is 17. Now, they were very generous in telling you that you're going to have 2 triangles, but how do we know that we have the option for the ambiguous case? Because they give you angle side, which is where the ambiguous case shows up. So, what I suggest you do, because they do want you to solve for the both triangles, meaning that you have to find everything. Talk to me about case 1 versus case 2, and then we're going to put all our info here, and then we'll do our math kind of down here. All right, so we have to start with law of sines, because we have angle side. So law of sines starts with sine of 39 over 12. And then the only other clue you have is angle B. So you're going to have to take the inverse sine. On your calculator, please, could you calculate degree mode, sine 39 times 17, and then divide it by 12. But remember, this is still the sine function, so at the very end you have to take the inverse sine of that little decimal. And what you're finding right now is the first option for angle B. And what do you get? Is it, what do you get? 63.1? Okay. Oh, does it say? Oh, it does say to round the angles to the nearest degree. I don't know what I put on the key. I'm okay with keeping tenths place. That's, I understand. So here's where, me personally, I split over to case 2. Because this is where you have to figure out the other option for B. Sometimes the other option isn't actually an option when we investigate it. But B could be, instead of 63.1, it could be the supplement to 63.1, which is 116.9. Okay. So this is where I have to stop and think, is that even a possibility? So this angle right here, could it be 116.9? 39 plus 116.9, are you still under 180? Yep, so we got to keep going, guys. We have the ambiguous case. Here we go. So angle B, found it in both cases. The next thing I need you to find for me is angle C. That should be an easy geo question. And then the other thing we're going to have to find is side C. So I think from here, I'm not going to ask you to do this on a test where you have to solve for the whole triangle in the ambiguous case. I just have you find angle B, both options, and then stop. Although I do not tell you that there's two options for angle B, so you have to know that. So anytime the ASS postulate shows up, you have to go, uh-oh, could be the ambiguous case, which it probably is. So go find angle C in case 1 for me. If it's 63.1 minus or plus 39, take those away from 180. What'd you get? A little louder. Thank you. And then to find leg C, you are going to have to set up law of sines. So this is kind of confusing for kids because they have like that one picture. If this picture is confusing you, then just draw 2 separate triangles for case 1 and case 2. But we're going to set up these. It's going to look basically exactly like this. So sine of 39 over 12. Except this time I'm trying to find C. So you're going to do the sine of angle C, which you just found, over leg C. So when you go to calculate leg C in case 2, I'm going to stop my work on this question. You guys are going to finish it. It's going to look really, really similar, except right here, you're going to get a different angle for angle C. So therefore, it's going to change the length of the leg. Welcome to the ambiguous case. It's super fun. Twice the work. All right. So that's what you got to do for 19. Best wishes to you. What else you got? I'll stay on that assignment maybe. There were some doozies on there, especially the story problems. 11. Okay. So 11, find all solutions. It's possible that there's no solution. So that's some ominous directions there, isn't it? Let's take a look at number 11. So same assignment. This time we're at number 11. And it says leg A is 14, leg B is 15, and angle A is 117. So, whatever. You should technically try to draw a triangle that makes sense, but we're talking me here, people. All right, 117 degree angle. Leg A is 14, and then leg B is 15. So we do have angle side side, so there's always the possibility for the ambiguous case here. But good news, there's also the possibility of no triangle. So that's exciting. Let's try law of sine setup and see what we're working with. So sine of 117 over 14. And then we only have leg B, so you're going to have to solve for angle B next. Sine of angle B over 15. So on your calculator, practice typing this, please, guys. Sine 117, close that, times 15. There we go. Then divide it by 14, and then don't forget at the end of this problem to take the inverse sine. And what'd you get? You got a birthday present right there. No solution. So when you do that step and it gives you like error, I don't know what message it gives you, but an error message. Oh, that's what happens. Yes, yes. Sorry about that. So it gives you an angle measure of what? Thank you. So the little robot child that I used to be in high school, I probably would have beep-bop done the rest of my problem and then never noticed that my triangle didn't add up, guys. 117 degree angle plus 72.7 degrees. Why is that a problem? It's way more than 180. So this is a case where there's no solution. Bit of a trick question. So do watch out for that. No such triangle is another way to answer that. All right, what else you got? Nothing on that assignment? Okie dokie. The area assignment, page 299, those few questions at the end there. Told you area wasn't that bad. Pretty nice formulas. Okay. You need to back up to, I'm very concerned about page 277, that last question. Can we look at that last question? Okay. So the inverse function graphing stuff, what am I doing? Insert link page. This is page 277, 78, and number 37, I think, is the one I was looking at. Yeah. So we're going to do a whole lot of this coming up in the next trig unit where you solve with your calculator, but this is just a brief little intro to it. It says find the values for theta between negative pi and pi for which this is true. So the equation they give you is cotangent of theta equals 2 secant of theta. And then that clue up at the beginning was that theta has to be between negative pi and pi. That's a really important clue for our graphing. So I said graphing because this is where you're going to grab your graphing calculator. In y1, you need to type this side of the function, but someone remind me, how do I type cotangent? 1 over tangent, yep. Ooh, someone else remind me what mode I should be in. Radian mode, which is unfortunate because you're probably going to have to flip back to degree mode in a minute. All right, so radian mode. For y2, how do you type 2 secant? 2 times 1 over cosine. Very good. So this is what you're typing in y1 and y2. And then for your window, I want your x's to go from negative pi to pi. So x min, x max. Then I want you to hit zoom trig, because you've defined your theta to go from negative pi to pi, and then it will manually adjust everything else for you. And you're going to see some weird horseshoe looking things, and then you're going to see a weird cotangent graph, and they're going to cross apparently twice. So you guys need to find the intersection points in that window where they cross. So use your intersect feature, second trace, intersect, and then enter, enter, enter. Just make sure you're scrolling along to find both of those intersection points. Please do practice that. I know at this point you guys are thinking, I'm just going to write down the answers. Humor me. I'm going to pause the video. Y'all going to practice that right now. All right. Blue worksheet on modeling. I would say one of the best things you guys can do to prepare for seeing modeling again on the next test, go back to your old test and fix those problems. Do both of them. Because that's very typical of what you're going to see on the test, okay? And if that means you got to come in and ask some questions, that's fine. So, with that put aside, let's talk about the blue worksheet. Which question do you want to look at? Number 1. Starting off strong, number 1. Now, first of all, did I assign you number 1? I'd hate to do extra questions. Yeah. Okay, good. All right, number 1. A Ferris wheel. So, I don't go anywhere on modeling questions without a picture, because I just can't. So, first thing I'm going to do is I'm going to draw a really horrible picture. A Ferris wheel has a radius of 10 meters. A person gets on at the bottom of the ride at a height of 2 meters, and there's some information about the rotation. So, the axes, that's the vertical axes, should be a pretty easy one for us to fill out because they flat out told you the information, kind of. One of the clues is kind of sneaky. How low is the bottom of the wheel? Where's the very bottom point? 2 meters. Now, the clue about the radius is a bit of a trick question. The radius is only half of the wheel, right? It's not the diameter. So if the radius is 10, the diameter is 20. So how high up are you? When you start at 2 and then rotate up 20 meters, you're up to 22. Now, the other thing I would suggest you fill out right now is the midline. So some of you can visualize where the midline is. Some of you are like, I don't know what's happening. The midline is that K value where you go max plus min divided by 2. So that's 12? Yes? Okay. So you have really 2 of the 4 pieces of information probably in this trig function already ready to go. You have the midline, so when I go to write your function for h equals later on, that midline of 12 goes right here, plus 12. I think you also can see the amplitude. We haven't talked about sign of the amplitude value in front yet, but how large is your amplitude? And if you're not sure by the visualization of it, you can calculate it by doing max minus min divided by 2, but it is a 10. Now, while we're here in the function, this is a graph that is going to start at the person starting at the bottom of the Ferris wheel, right? And then they're going to do one of these. So tell me something else about this function you know. It's cosine, and it's upside down. So this has a negative in front of the 10, and it's cosine. So you're really close to done with this question. I knew there wasn't going to be a phase shift in this question because it never said anything about, like, I don't think it did. I didn't really keep reading. Yeah, at no point in the setup did it say something like he started the timer at some weird point. There wasn't a clue about a phase shift, so there's no phase shift here. So the only thing you guys are going to have to figure out for me is what's going to go in place of your B value here. So someone remind me how we calculate B. It's 2 pi divided by the period. They must have given me a clue about the period somewhere in this question. It says it makes 1 full rotation every 20 seconds. Guys, that right there, that is period. So the period is from beginning to end, it's 20 seconds. So throwing that into this formula, 2 pi over 20, better known as pi over 10. Very good. So that was a pretty basic one. Okay. Why did I do that whole thing for you? That was stupid. My bad. I think for some of us, we kind of missed, oh, you know what? I think I didn't read directions. It did say sketch for 2 revolutions, so you guys need to keep it there. I won't do that part. You guys need to keep going. Do another revolution, and can you mark up some time maybe on your axes? Yes, please, thanks. Now, I will not do the follow-up question where it says use your equation to determine the height of the rider after 6 seconds, because y'all got this. You just got to plug in a 6. You can... Don't do it. What mode should you be in, though? Radian. Anytime you're graphing for trig functions, it's got to be in radian. So you can plug in 6 in the home screen. You can choose to go to the graphing calculator's, graphing mechanism if you'd like. I think that's a little overkill for that question, though. I feel like none of these had phase shifts. Let me look. The low tide question's fun. Did I assign that one? That's a hoot. There is a phase shift, like when you get to number 8. But I feel like, yeah, that's really the only time that's popping up on this worksheet. Do you need any help setting up any part of the graph? I really truly feel, guys, that some of you just, like, had you started with the graph component of it, you would have had a lot of success on that last test. And I'm not saying none of you had success on it. Some of you were very correct or very close to correct the last time we tested it. We're going to have to see it again. What'd you think? Anything more on the blue worksheet? Okay. So, good news. I have time to look at the review. What you got? So on the review, some sections that are repeating themselves are advanced graphing, 4.4b. That's the stuff where you're graphing with a phase shift. You're also writing the equation based off of a graph. You're really diving deep into how do you find b, what does it mean for period. And then modeling shows up again. And then the new stuff would be the graphing, the cotangent, secant, cosecant, tangent. I'm going to ask you to graph like a couple periods of it, and then also identify like where are your asymptotes for tangent. Well, all of them. Where are your asymptotes, and then where are your like midline intercepts. We've kept those functions really super basic. Like we're not going to give you a tangent that has a phase shift that, has a weird period. It'll have like one thing weird about it, not multiple things. And remember on your blue or salmon colored formula sheet, there's a lot of good information about tangent, cotangent, cosecant, secant. So do you not need me? Do I get to go get coffee? The back is all this law of sines and cosines business. With some area formulas. Again, those are given to you. What is not given to you though? What formulas do you need to have memorized because they happen to be questions?
Well,
Law of sines and law of cosines. So just one version of them, please, but law of sines and law of cosines.
So you're going to give us both versions of the area?
Yep, I give you Heron's formula and the other one doesn't have a name, but that one, yes. So they're weird. They're like, one's in a box on the bottom and one's on a box on the side. Like, yes, so same side as that, but somewhere else there's another box. We had to kind of sneak them in. So there's a huge note on your test, like when you hit the law of sines and cosines part, where it says, change your calculator to degree mode. Because up until that point, you should have been in radian mode. So we're all going to start the test going, everyone's calculator in radian mode, and then you're going to flip it. And I'm going to be really sad if you don't notice your answers are weird when you forget to flip it. They're pretty obvious. Like, you shouldn't get an angle of 1.2 degrees on your law of sines questions, you know. Well, guys, I feel useless. Do you have any questions?
Let's do the one where you drew a swamp around
Oh, who? What?
Number 2, 4.7.
Oh, okay. So 4.7 part A or B? The applications part? The bottom? Okay. So we're on the review. Very last question. All right, so some students are assigned a task of measuring distance between two trees. So there's a little picture there. I do feel like, man, I should have looked this up before class. I think this question on the test, there's no picture drawn. So part of your challenge is going to be to draw the picture. It's a pretty easy picture, though. I think it might be, like, I don't know. I'll have to look at it again. It's an easy picture. But if you have questions with, like, did I set my picture up right, I would be okay with telling you yes or no. I'm not going to help you set the picture up, but if you are worried that you put a number in the wrong spot, then I can kind of help you with that. All right. So some students are assigned a task, blah, blah, blah. Okay. So A to B is what you're trying to find. And then they've done some weird surveying work. This is part C. And they know that this angle here was 27 degrees. I think this kind of a question where they talk about like the angles between two things, like it's not really clearly stated, so I'm happy that they drew a picture for me, but I can understand why you guys might be confused. There's a book problem that was kind of like this, where like an airplane went off course and you're like trying to figure out how to draw the picture. That was a tough one. The one on the test is not that bad. All right, so 27 degrees is here. I think there's another piece of information about angle ABC being 85 degrees. And then there's a clue about 150 feet is the length of AC. So you guys have angle, angle, side. So talk to me about which law you're using for angle, angle, side. Law of sines. So this would be a good opportunity to show me that you know law of sines. Throw out a version of law of sines for me, guys. Sine of... Well, I just want the formula. So like sine of A over A, capital over lowercase, notice, equals sine of B over B. Yep, something like that. You can even keep going and tell me it's sine of C over C. So now let's use one version of that law of sines to solve our problem. So the part of the triangle that's all filled out, I think we have it. You have angle B and you have side B. So we're going to set up the sine of 85 over 150 equals, and then we're trying to find x, so let's use the angle across from him. Sine of 27 over x. So if you're typing this problem in, you got to be in what mode? This is in degree mode. Sorry for all the flipping today. And I think you get 68.4. Okay, what else you got? The area stuff's pretty new to you, so make sure you're practicing those. That's that one book assignment that's got like 4 questions on it. Do you guys want to look at 4.4b? I feel like that was a big problem for some of our friends. The question that I'm particularly worried about is actually the very first question on the review. So if you don't mind, I'd love to look at that one. So I'm going to ask you to graph this. I want you to tell me everything you know about this. Okay, it's reflected. What else you know? The amplitude is 3. It's a cosine. So the shape is, it's going to be this, right? Phase shift. Okay, that's a vertical shift. So vertical shift is up 1. Phase shift is left pi over 2. What's the b value? 2. So what's the period? Okay, so 2 pi over 2 would be pi. And then this is the one I don't specifically ask you for, but I think would be really smart. What do you count by? Yep, so it's whatever the period is divided by 4. So for us, that would be pi over 4. All right, here's what I need you to do. I know there's no room, but you're going to help me draw it. So you guys told me we started with a left pi over 2 shift. So pi over 2 is a larger unit than pi over 4, right? So I'm going to call this left pi over 2, so negative pi over 2. And then I need you to help me remember, how am I going to start moving in this direction? Mathematically, what do I have to do to keep hopping from one point to the next? What am I counting by, is my question. We're adding pi over 4 each time. So I need you to decide how you're going to add pi over 4. Either with a calculator where you just type the coefficients and not the pi, or you'll go old school with me and you get some common denominators. Okay? So what is negative 1/2 pi plus 1/4 pi? Negative 1/4? Negative 1/4 pi? Okay. So if you're like, oh, the mystery of the fraction is eluding me today, what I need you to do on your calculator is type negative 1/2 plus 1/4 and then math enter, and then slap a pi on it. Okay. So negative pi over 4. All right, hop to the next place. If you add pi over 4 to that, where are you? 0. So the next mark is going to be at 0. And then your next mark is going to be at, I think we got it from here, pi over 4. And then the next mark is going to be at, so you can say 2 pi over 4 or pi over 2 when you reduce it. Good. So 1, 2, 3, 4, 5 points. That's all you need. Except I kind of forgot something really important. You guys told me all about my vertical shift and I didn't pay attention to you. All right, where is your midline? If everything was shifted up 1, that means your midline is up here at 1. And you guys told me the amplitude was 3. So you're going to have to count up 3 units here. So where are you at here for the maximum? Good. And then count down 3 units. So where are you here for the minimum? Negative 2. Good. And then hope for the best. A long time ago, you guys told me this was a cosine graph who had been reflected. So that very first point that you guys marked up is going to be, instead of the top, because it's reflected, it's now at the bottom, the minimum line. And then the next point you marked up for me is at the middle. Make sure you're on the right line. And then the next point is up here. And then back to the middle. And then down here. And that is not symmetrical. At all. Oh, that's ugly. Alright. So, phase shifting. It's a hoot. If you guys are getting stuck with the fraction work, I think this part right here, this is what a lot of kids were a little freaked out by on the last test. They're like, how do I go to the next point? Well, you're counting by period over 4, which we kept calling quarter points. I'm going to stop calling them quarter points since we have to worry about tangent now. But you're counting by pi over 4, which means you're adding pi over 4 each time, starting from the phase shift. All right, I have some time. You guys need to look at anything else? You know, I hate grading the next question because there's so many different options for like where you start your function. So, I mean, I wrote on the key where I started the function, and you might disagree and start somewhere else. Just note that there are more than one correct, there's many correct answers. But what I don't want to see, and sometimes I see this, kids shift like more than a period over, and then they're like, I'm starting here. Like if your period is pi, don't tell me like I'm starting at left pi. Like that's too far. If you're doing that, you're starting at 0. So, I think the one on the test this time is the graph is more easily read. I feel like the the ordered pairs were difficult to read on the last test, so apologies about that.
The next one, can you tell us how you found the period?
Yeah. So, unfortunately, I don't have a picture of it, but on the next one, the period, by definition, is the length of time it takes for the cycle to complete. So basically, I pick a random starting spot, usually the spot that I literally am starting, and then I pick an ending spot, hopefully. If you get in a jam, you can find a halfway point, Hunter, and then you can like double it after that. So for me, I'm looking at the start of the function being at pi over 3. And then the end of the function for that first cycle being at 5 pi over 6. And that's kind of a funky set of fractions to think about, like, okay, how far apart are they? So essentially you're just doing a subtraction problem. So 5 pi over 6 minus pi over 3, again, you can use your coefficients on your calculator, or you could trade this and say it's a 2 pi over 6. So the answer is 3 pi over 6, which is pi over 2. Yeah. So this is the period. It's hard to see when there's a phase shift. The period's not easy to tell. So then when you go to calculate b, that's a little formula you guys have to remember for me. b is 2 pi divided by the period. So instead of dividing by pi over 2, you're going to have to multiply by the reciprocal. The pi's are going to cancel, and you get a b value of 4. Okay. You really have to rely on your formulas for calculating b and period on that picture, especially with the phase shift. I mean, I think on that question, y'all have to have a phase shift, regardless of where you start. There's no nice place to start.
You said all of this is in radian mode until you tell us.
Yes, so the beginning of the test will be radian mode the whole way until you hit law of sines and cosines, and then there'll be a huge note on the test that says switch your calculator's mode to degree. So that's how you'll know. The modeling, I think the regression equation stuff went well in general last time. Some of you did not use your stored regression equation to find the answer on the follow-up question. It does very clearly state this time you must use your stored equation. So that means you must go to either y equals or the table with a stored equation. Don't use your truncated equation, please. All right. Please practice those secant, cosecant, tangent, cotangent graphing. I'm concerned that some of you never got around to doing that homework, and it makes me nervous. Okay, that's all I got.